Going to try to do here is talk about Boreas from a Canadian perspective, because that's where I was coming from at the time. I was U.S. born, U.S. educated, but I moved to Canada in the mid-1980s. So I had a Boreas voyage through life, as many of you have. I started studying forest ecophysiology, which at the time was primarily leaf level or seedling level type of stuff. Much like Jim Colatz, I was doing research in nursery forest tree seedling production. I became a professor at Laval University in Quebec City. And one day in the latter part of 1989, my dial phone rang. I answered it, and the person said, "Hi, I'm Diane Wicklund. I'm a program manager at NASA headquarters. We're putting together a workshop in Durham, New Hampshire, at the University of New Hampshire, to talk about an experiment in the boreal forest. Would you be interested in coming?" I thought, well, okay, I'll give that a try. I didn't actually know that much about the boreal forest at the time, because I was only been in Canada for a couple of years, and I was working, not a student. So I take a flight down to Boston. I get in one of those van shuttles up to Durham, and there was this guy I just met, Frank Shuttleworth, and we're driving up to Durham, and by the time I got there, I was a little nervous, and I'm thinking, well, this is going to be different. And I walk in, and of course I met Piers and Forrest, and the rest pretty much followed. So I got involved with Boreas. It was opened the whole world for me. I had no idea we could be doing this kind of stuff. I actually had no idea you could have these budgets that were involved with Fife and Boreas. For me, they were massive. At one point, we did a couple workshops. I got a letter from, I believe it was from Diane, saying, well, if you're interested in doing anything with the leadership, you need to write to the Canadian government and let them know you're interested. So I wrote a letter to some Deputy Minister of Natural Resources Canada, and got a letter back saying, thank you very much for your interest, but this is a big project, international, and we'll get back to you should we need your services. And so a little while later, I get a call from Joseph Selar inviting me to Ottawa. I walk in the room, Diane's there, Ray Desjardins was there, Barry Goodison, Joseph Selar, a number of others, and we started to talk about this possibility of ramping up the Canadian contribution and doing a grant to the big funding agency for university science in Canada called NSERC. And that led to the Canadian University participation in Boreas, which was really quite significant. That got me, obviously, collaborating with Goddard. I started to do sabbaticals at NASA Goddard, ended up doing 3 of them over the years, and worked with many of the people at the Biospheric Sciences branch/lab. Then moving on towards the FlexNet Canada endeavor, which built on Boreas, I'll talk about in a moment, which led to the Canadian Carbon Program. And then I had this amazing stroke of luck about a little over a year ago, where I got offered the position to take over for Diane as a program manager for the terrestrial ecology program. So that's my Boreas voyage. In a nutshell. Uh-oh. Jessica?
The rescue is coming, don't worry. At least you didn't get that Microsoft.
I just pushed the button like you told me.
I think you stepped on the wire.
Well, what did you told me to? The one with the arrow there, right?
No.
Check your wires, Hank.
Oh.
You press this.
Did I really? Okay. Okay. Sorry.
Right.
Yeah. Okay. Obviously I've got big shoes to fill. It's really a blast, though. I got to put in a good word for headquarters. You hear a lot of stories about it, but it's really a great place to be and a great place to work. It's a huge variety of different things that happen every day. There's a fair bit of adrenaline to it, I got to tell you. So the Boreas NSERC Collaborative Special Project, it went for 5 years, and it involved 12 different research projects, which was really huge at the time, 25 Canadian co-investigators, 41 graduate students and postdocs who have since gone on to great things. Now, it was quite a big interest in Canada regards to Boreas. It was actually a fairly easy sell at the time because Canada is really large, 45% of North America, and 10% of the world's forests. So what we did is, following Boreas, we had this group of scientists that knew each other really well, were familiar now with the kinds of technologies like the flux towers that were a big part of Boreas. And so we tried to build on Boreas. That became a lot more feasible after the Kyoto Protocol was ratified in Canada, and there was some interest in doing something. And we had the group, because Boreas brought us together. So what we tried to do is to build on the lessons from Boreas. We said, well, long-term measurements going for multiple years, and we were able to do we had a 10-year run with FluxNet Canada, which was good. Scale it up to a continental scale. Let's try to do it all across Canada. And so these various Boreas Canadian PIs got populated across these various red dots that you see here. Let's worry about the calibration part of this thing and the standardization. Let's actually buy the same equipment. Everybody buy the same model of radiometer and the same model of light core, and let's try to use the same data processing algorithms and such things like that. And then lastly, the fourth lesson was let's look at disturbance. Boreas was largely the mature stands. There were a couple young ones there, but we wanted to hit hard the issue of disturbance and, of course, interannual variability because we were going multiple years. So this is what the network of FluxNet Canada looked like, going east to west. And it was, like I said, I think pretty much all Boreas, except for New Brunswick. Everybody was got their ship legs during Boreas. Okay, let's push the right button. So much like Boreas, the idea was to make intensive high-quality field measurements of biosphere-atmosphere fluxes and combine them with remote sensing and test the predictive models. And Eric mentioned that. And this is what it looked like when you put all the data together. A really nice part about doing the FluxNet Canada was you can present a lot of the results in one graph. So these are the different sites, stand age for the forest sites. We had peatlands as well. So stand age on the x-axis, carbon flux on the y-axis, and you see this pattern that's made its way into quite a bit of models since then. The same point plotted multiple times, like those blue dots in the center there, that's the old Aspen site. That gives you an idea of how interannual variability kind of plays out across the chronosequence.
Is there the northern site there?
The northern site is the black dots. The northern black spruce site is the black dots on the edge. Yeah. Okay, so So the archive data set is really our major legacy, much like what we see for Boreas. We 185 site years of flux data from 34 sites. The ecological data stored at Oak Ridge, at the Oak Ridge DAC now. And it's very actively downloaded to this day, and I'm optimistic that that's going to continue. So building on Boreas, it was the human interaction. Our group became a really tight-knit group that worked very well together. We recruited Forrest and a bunch of people from Fred and a number of people from Goddard to participate as well. Steve Welsey, of course, was involved. And so one of the things we could do is compare across black spruce sites located in different parts of Canada, building on the Boreas sites at the southern old black spruce in Saskatchewan, the northern old black spruce in Manitoba, and then eastern old black spruce in Quebec. Just to throw up a quick result here, this is the net ecosystem productivity. We see that, modest sink for the 2 Boreas sites, and the eastern Canadian one was in Quebec was basically it was carbon neutral. Yeah, it wasn't just, and it had like no interannual variability, which is really a pain when you're trying to get funding for continuing. And basically what's going on, or what was going on, is that in eastern Canada we had a larger snowpack that insulated the soil early on and kept it quite a bit warmer, and so the steeper snowpack, warmer temperatures in the soil, and a lot more wintertime respiration, which is shown in that slide. So we couldn't keep interest for the funding agencies much past 10 years. It's a challenge, but things kind of broke up, but we still had that core Boreas group with this interest in running these towers and keeping things going. And this is a more current version of what's going on. A lot of the sites, not all of them, are still going. Particularly the Saskatchewan site, the berms, is been pretty much continuous since they were set up in originally in Boreas, and they just got the University of Saskatchewan just got this mega grant of like $100 million for global water security. The previous version of that had funded the towers, and I feel pretty confident that with all this massive amount of money they got, the towers are going to continue for quite a number of years there. So it continues. These are some of the folks that are continuing it. A lot of them were either Boreas PIs or students of Boreas PIs. So that's you know about all the southern black spruce. That's the various incarnations of funding. I just talked about that. So these sites are still operational. Okay, yeah, so what I want to do is just give an example of what I think is some cool research, more recent research result from the Saskatchewan sites. So that's, you probably all recognize this, the White Gold Creek watershed with the different flux towers. Some of them were added on after Boreas. And what happened in the late 90s, there was a very significant drought. Graph and stream flow in the lower graph. From the late 90s, for a number of years there was a pretty significant drought period, and then eventually it started to come back. So perhaps just fortuitous, perhaps extremely acute scientific planning on the part of the yellow diamonds there are the flux towers. White Gold Creek is the there. And so this is gravity water storage, in this case, an increase over the time period. So coming back from the ground. I didn't even notice. Okay. So this is some work Tony Lambert at Natural Resources Canada put together, and so it's looking at the gravity anomaly. The grace measurements are the black dots, and so you see this kind of increasing increase in the gravity anomaly, I guess that's how you say it, over time. The blue little, you see a couple blue lines there. Those are some measurements where folks went out and actually measured the soil water in various places and then did some calculations. And the red line there is precipitation, measured from precipitation, stream flow, because White Gull Creek is a gauge watershed. And the E star there is the energy budget corrected evapotranspiration, which comes from the flux towers scaled up with land cover and all. So P minus E minus stream flow gives us the water storage term, and you can see the red line that it tracks the GRACE results really quite closely. So here, quite a good legacy for Boreas that was actually able to make use of the GRACE data and show up something of very strong significance over a 10-year time frame. So we have added on some other sites. There's Daring Lake now, up in the Northwest Territories. Oliver Sonatag's got this Taiga Plain transect that's now currently running as a flux site. And these are an important part of ABOVE, the Arctic Boreal Vulnerability Experiment. We're very much into ABOVE right now. We're planning this airborne campaign that Scott Getz mentioned, keeping primarily these solid black lines there, where we're going to get a lot of NASA airborne resources out into the field in 2017, if all goes according to plan, and get a science team out that, again, builds on what was done and accomplished during the Boreas timeframe. I would mention that we have an ABOVE coordinating group, what we call the ACG, which be kind of familiar to Diane and others. Basically, we get together and we talk with the Canadian managers at the different agencies, Natural Resources Canada, the Canadian Forest Service, the new version of Canadian Centre for Remote Sensing. We actually have the Canadian Space Agency that comes on the calls. They're actually involved, which was not so much the case during the Boreas time. So we build on the relationships that we built up during Boreas to continue through ABOVE, and we have really strong, good relationships with the Canadian government still to this day, and they're very much interested in participating and advancing the objectives of ABOVE. So these are some of the Boreas grandchildren, and came students and postdocs from FluxNet Canada. I did want to just add on, I just added on this just because I got an email yesterday. There's this is a little bit off topic, but Avarice was part of Boreas, a big part. And one thing that kind of showed up, the SpaceX Falcon 9 blew up on the launch pad down at Kennedy on September 1st. And they had the idea of let's take Avarice out there and see if it can detect debris. And it was a really exciting kind of a series of events that I won't go into. But on September 28th, they did the flights, did some data processing, and seemed to got 14. Well, you can't even see them. It's these little red dots that barely show up there, kind of in the lower part there. That's the launch pad 40, right near where Piers blasted off. On the, let's see, if I walk, all right. Yeah, this is launch pad 40 here. So they went out and they found 14 anomalous areas that looked like it could be SpaceX debris. And of course, this hurricane was coming. And so SpaceX rushed out 2 days ago, I guess, and sent out 5 different teams. One of them found a balloon, the other found a plastic bag, another found a bunch of alligators, another team ran into a yellow jacket nest. A bunch of people got stung and they had to retreat. But Team 5 found debris. And some significant debris as well. Parts of the satellite that blew up, the internet satellite, and some pieces of the skin of the rocket. So it was pretty exciting, and they, like I said, just went out yesterday right before the hurricane hit. So as you said, just to finish, Boreas obviously had a big impact on me, very positive. It's still having an impact. It changed research in Canada in a very significant way. That's still going on, and through Above, we're going to push it on into the future. So thanks.